Since the early days of mainframe computing, our relationship with machines has followed a rigid protocol. A human provides a specific, deterministic command, and the computer executes it. Without that input, the system remains inert. The first wave of generative tools appeared to break this cycle, but the underlying mechanic remains the same. We provide a prompt, the machine provides a response, and then it waits. We are still responsible for every turn of the wheel. This is the limit of creative output. While these models can produce high-quality code or images in seconds, they require a human to manually connect every result to the next task in a sequence. This creates a persistent bottleneck. Even as digital tools become faster, the workflow still moves at the speed of a human operator, making every individual decision. Most modern digital workspaces are filled with this untapped potential, powerful systems that spend most of their time waiting for the next instruction. To visualize this, imagine a paintbrush that can instantly render any style or subject with perfect precision. It is, technically, the most capable tool ever built. But the brush cannot move itself. It possesses no autonomy. Without a human hand to guide it through every single stroke, it remains a stationary object on a desk. Solving the current productivity limit means moving beyond tools that wait for instructions and towards systems that can manage their own execution. Agentic AI changes the nature of the interaction. Instead of micromanaging tasks, the user provides a high-level mission and leaves the steps to machines. This capability is driven by structured cognition. The system takes an abstract goal and applies logic to break it down into a sequence of actions. If a specific step fails, the agent analyzes the error and finds an alternate route without human intervention. There is a sharp distinction here. Generative models focus on building the asset, while structured cognition focuses on building the plan. By internalizing the planning process, the machine moves from a reactive assistant to an autonomous operator. We can see the difference by returning to the paintbrush. A standard generative task is simple. Ask the system to paint an art gallery. The system generates the image, the task completes, and the software returns to an idle state. Now consider an agentic mission. Prepare a gallery opening. The agent creates 3 parallel workflows. It paints original works, researches critics, and drafts outreach simultaneously. It then secures a venue and schedules the event, managing the timeline until all tracks converge on the final objective. The distance between generating a single image and coordinating a complex event is what we call the execution gap. Agentic AI is designed to automate the multi-step reasoning required to bridge it. This shift removes the need for humans to track every minute detail of a digital workflow. We are moving away from the role of software micromanagers. Our work is becoming that of a director, overseeing a fleet of autonomous agents. Instead of checking a single line of code or a single paragraph, oversight focus shifts to the overall success of the mission and how well it aligns with broader strategy. The machine handles the specific execution of the how, while the human operator provides the what and the why. The rapid progress in generative models provided the core logic needed for this transition. Those tools are now being integrated into these larger, mission-oriented systems. The long-standing requirement for one-to-one manual machine instruction is being replaced by a model of delegation. Now our role is to set the high-level intention, step back, and let the system execute.